There are nights when the moon hangs above the Earth, like a question written in silver light, perfectly still, perfectly familiar. Tonight traveller imagines standing on a quiet plain long before history began, watching that same pale disk rise, for the first time altering tides, shadows, and time itself. You're not here by accident. Something ancient has guided you to this moment of listening. What if the moon was not born of chaos, but placed with intent? Science tells us it is 400 times smaller than the Sun and 400 times closer to Earth, an alignment so precise it creates perfect eclipses again and again across forgotten epochs. Like a message hidden in orbital mathematics, the moon casts a shadow that fits too well, lingers too long. Let's drift a little deeper. The moon occupies a position in human understanding that feels deceptively simple. It rises, it sets, it governs tides, and it marks the passage of months. For centuries it has been treated as a passive companion, a natural satellite formed by ancient violence, and left to circle the Earth in mechanical obedience. Yet when examined closely through physics, geology, astronomy, and the earliest historical records, the moon begins to resist that simplicity. It behaves less like debris and more like a system. Modern science proposes that the moon formed from a colossal impact between Earth and a Mars-sized body early in the solar system's history. This explanation is widely taught because it offers a narrative consistent with planetary formation models. However, many of the moon's measured properties sit uneasily within that framework. Its size relative to Earth is unusually large, its orbit is unusually circular and stable, its placement is unusually effective at regulating Earth's axial tilt, stabilizing climate over geological time. Each of these facts can be explained individually, but taken together they form a pattern that demands closer scrutiny. One of the most striking scientific observations comes from seismic experiments conducted during the Apollo missions. When spent rocket stages and lunar modules were deliberately crashed into the moon, seismometers recorded vibrations that lasted far longer than expected. On Earth, seismic energy dissipates rapidly through dense, heterogeneous material. On the moon, the vibrations persisted sometimes for hours, propagating through the lunar interior as if moving through a rigid shell with internal cavities. The phrase rang like a bell used by researchers at the time was not metaphorical. It was a technical description of an object whose internal structure did not behave like a solid planetary body. The implications of this behavior were never fully resolved. Instead, they were absorbed into the growing archive of lunar anomalies, facts that are acknowledged but rarely emphasized. Subsequent studies suggested that the moon has a disproportionately small core, inconsistent with its mass and density. Yet despite this, remnant magnetism has been detected in lunar rocks, indicating the presence of a magnetic field at some point in its history. For a body of its size and composition, such magnetism should have faded early. Instead, it appears localized, patterned and persistent in ways that complicate standard models. Orbital mechanics introduce further difficulties. The moon is currently receding from Earth at a measurable rate of approximately 4 centimeters per year. When this motion is projected backward, the results conflict with geological evidence. If the moon had always been moving away at this rate, it would have been catastrophically close to Earth in the distant past, generating tidal forces incompatible with the survival of early life. This discrepancy, known as the lunar recession paradox, suggests that the moon's orbital history is not a simple extrapolation of present conditions. Something changed, something intervened. The geometry of the Earth-Moon-Sun system adds another layer of improbability. The moon is approximately 400 times smaller than the Sun, yet also approximately 400 times closer to Earth. This coincidence produces perfect total solar eclipses events in which the moon precisely covers the Sun's disk, revealing the solar corona. No other known moon-planet system in the solar system produces eclipses with this level of precision. The odds of such alignment arising by chance are extremely small, and while improbability alone is not evidence of design, it is a statistical feature that demands explanation. Compositionally, the moon presents additional contradictions. Lunar rock samples show oxygen isotope ratios that are remarkably similar to Earth's, supporting a shared origin. Yet other elemental abundances do not align with predictions from the giant impact hypothesis. Some lunar materials appear older than Earth's oldest known rocks. Others show signs of formation under conditions that do not match the Moon's current environment. These inconsistencies have produced a proliferation of competing theories, none of which fully account for all observed data. Beyond physics and geology, the historical record introduces a different kind of tension. Ancient cultures across the world preserve traditions that describe a time before the Moon. Greek writers such as Aristotle and Plutarch reference peoples who lived under a sky without a lunar presence. African oral histories speak of changes in tides and seasons following the Moon's arrival. Mesoamerican and Aboriginal traditions contain similar accounts, often describing the Moon not as eternal, but as something that came into the sky. These accounts are typically dismissed as myth, yet their consistency across geographically isolated cultures raises questions. Myths often preserve memory through metaphor and coding environmental changes into narrative form. If the Moon has been present for over 4 billion years, there would be no human memory direct or inherited of its absence. The persistence of these traditions suggests either a remarkable coincidence of storytelling, or the preservation of observations tied to an event that occurred within the span of human or pre-human experience. Archaeological evidence offers subtle reinforcement. The earliest astronomical monuments tend to emphasize solar and stellar alignments, rather than lunar ones. Lunar alignments often appear in later construction phases, as if ancient observers were adapting to a new or newly significant celestial influence. This progression is difficult to reconcile with a Moon that had always dominated the night sky in its current form. Taken together, these scientific and historical anomalies do not prove that the Moon was constructed or deliberately placed. What they do demonstrate is that the Moon does not fit comfortably into existing explanatory frameworks. It behaves like an object with internal structure, orbital precision, and environmental influence that exceed what chance formation would predict. It appears less like a remnant of chaos and more like a stabilizing mechanism. The Moon governs Earth's tides, moderates its climate, slows its rotation, and contributes to the stability necessary for complex life to develop. Without it, Earth would likely experience extreme axial variations, violent weather systems, and diminished biological diversity. These effects are not secondary, they are foundational. The Moon does not merely accompany life on Earth, it enables it. This realization shifts the question from origin to function. Rather than asking only how the Moon formed, it becomes necessary to ask what it does. In systems analysis, function often reveals intent more clearly than origin. A structure that stabilizes, regulates, and sustains may not be accidental, even if its beginnings are obscured. At this stage, certainty is neither possible nor necessary. Science advances not by closing questions prematurely, but by allowing unresolved patterns to remain visible. The Moon remains one of those patterns. It hangs above Earth as a physical presence and an intellectual challenge refusing to be reduced to a single explanation. Whether natural or engineered, accidental or deliberate, it represents a convergence of forces that made human history possible. Some mysteries are not solved quickly because they are not meant to be. They persist quietly, exerting influence, shaping outcomes while inviting reflection. The Moon is one of those mysteries, silent, enduring, and still asking questions long after the first answers were written. If the Moon is approached not merely as an object of origin, but as an instrument of influence, its role in Earth's history becomes more difficult to dismiss as incidental. The physical presence of the Moon reshapes Earth on every measurable scale, from ocean dynamics to atmospheric stability, from biological rhythms to geological timekeeping. These effects are not subtle, they are structural. Without the Moon, Earth would not simply be a slightly different planet. It would be an unstable one. One of the Moon's most significant contributions is the stabilization of Earth's axial tilt. Earth's axis is inclined at roughly 23.5 degrees, a configuration that produces predictable seasons and relatively moderate climate zones. Computer simulations show that without a large Moon, Earth's axial tilt would vary chaotically over time, swinging between extreme angles. Such instability would lead to severe climatic oscillations, rapid ice ages, and mass extinctions that would make the long-term evolution of complex life unlikely. The moon acts as a gravitational anchor, damping these oscillations and maintaining long-term environmental continuity. Tidal forces provide another example of disproportionate influence. The moon's gravity generates tides that do far more than move oceans up and down coastlines. Tides drive large-scale ocean circulation, mix nutrients, regulate coastal ecosystems, and may have created the intertidal zones where early life transitioned from water to land. These zones expose organisms to cyclical stress, wet and dry light, and dark conditions known to accelerate evolutionary innovation. Without strong lunar tides, Earth's oceans would be more stagnant, and the evolutionary pathways that led to terrestrial life might never have opened. The timing of biological rhythms further complicates the picture. Many marine species synchronize reproduction with lunar cycles, releasing eggs and sperm at precise phases to maximize survival. This synchronization is extraordinarily accurate and widespread across unrelated species. It implies not a slow, random adaptation, but a strong, consistent environmental signal acting over a relatively short evolutionary window. Human biology shows echoes of this pattern. The average menstrual cycle closely mirrors the lunar month, a correlation that has been observed across cultures and epochs. While not universal, the statistical alignment is difficult to ignore. From an evolutionary perspective, these patterns suggest rapid adaptation to a powerful external regulator rather than gradual fine-tuning to a weak background influence. This raises an uncomfortable possibility that lunar influence intensified at some point in Earth's biological past. Such intensification would be consistent with a moon that arrived or was repositioned within a time frame meaningful to life rather than deep planetary prehistory. Geology offers indirect support for this idea. Tidal friction caused by the moon is responsible for gradually slowing Earth's rotation. Early in Earth's history, days were significantly shorter. As lunar tides transferred angular momentum, Earth's rotation decelerated to its current rate. This slowing had profound consequences. Longer days allowed for more stable weather systems, reduced atmospheric turbulence, and more predictable biological cycles. These changes correlate with periods of rapid diversification in the fossil record. Again, the moon appears not as a passive byproduct, but as an active regulator of planetary conditions. The moon's orbit itself displays characteristics that appear optimized for long-term stability. Its nearly circular orbit minimizes extreme tidal variations, while still maintaining sufficient gravitational interaction. Its synchronous rotation, always presenting the same face to Earth, is often described as a natural outcome of tidal locking. While tidal locking is common among moons, the precision with which the moon's rotation matches its orbital period is remarkable. The far side, hidden from Earth for most of human history, displays a markedly different geology, thicker crust, fewer maria, and a surface that appears older and more heavily cratered. This asymmetry has no universally accepted explanation. If the moon formed uniformly from debris around Earth, both hemispheres should show broadly similar characteristics. Instead, the moon appears divided into two distinct faces, one smoother and more geologically active, the other more ancient and inert. Some researchers have suggested that this asymmetry reflects internal structural differences rather than surface processes alone. Gravitational mapping missions have reinforced this suspicion. Dense mass concentrations beneath the lunar surface, known as mascons, create gravitational anomalies that affect spacecraft orbits. These mascons are not randomly distributed. They appear associated with large impact basins, yet their density and depth exceed what impact processes alone would predict. Their regularity has led some scientists to describe them as structural rather than accidental features. When considered collectively, these factors challenge the notion of the moon as an inert relic. Instead, it behaves like a dynamic system that interacts with Earth in finely tuned ways. Systems theory teaches that when multiple independent variables align to produce stability, regulation, and feedback, the system as a whole often reflects design principles, whether natural or artificial. In biology, such systems are rarely accidental. In engineering, they never are. Historical consciousness adds another dimension. Ancient civilizations invested enormous effort into tracking lunar cycles. Calendars, agricultural planning, ritual timing, and architecture were often structured around the moon's phases. Megalithic sites across Europe, Asia, and the Americas encode lunar standstills, nodal cycles, and eclipse patterns that require centuries of observation to calculate accurately. The knowledge embedded in these structures suggests long-term systematic study rather than casual skywatching. Curiously, this intense lunar focus appears abruptly in the archaeological record. Earlier structures emphasize solar alignments. Lunar precision emerges later as if ancient societies were responding to a growing or newly discovered influence. This pattern mirrors the historical accounts describing a time when lunar cycles were still being learned, refined, and integrated into human understanding. None of this conclusively demonstrates that the moon was built or deliberately placed. However, it undermines the confidence with which purely accidental explanations are often presented. The moon's influence is too central, too stabilizing, and too well matched to Earth's needs to be dismissed as coincidence without scrutiny. At minimum, the moon represents an extreme outlier in planetary science. It occupies a narrow corridor of possibility where life climate and time itself remain coherent. Slight deviations in mass distance or orbit would render Earth far less hospitable. Whether this corridor was entered by chance or intention remains an open question, but the corridor undeniably exists. Scientific humility requires acknowledging unresolved patterns rather than smoothing them away. The moon continues to resist reduction, refusing to become just another satellite in a catalogue. Its presence defines Earth's past and shapes its future. In that sense, the moon is not simply an object to be explained, but a condition that made explanation itself possible. Some questions persist not because evidence is lacking, but because evidence points in too many directions at once. The moon stands as one of those questions, visible, measurable, influential, and still fundamentally unresolved. If the moon's physical influence can be described in terms of stabilization and regulation, its deeper mystery lies in what it suggests about intention. Scientific inquiry traditionally separates natural process from purposeful construction, yet there are moments when the boundary between the two becomes difficult to define. The moon occupies precisely such a boundary. It functions too well for too long, and across too many independent systems to be easily dismissed as an accidental byproduct of cosmic violence. The question becomes sharper when the moon's internal structure is considered. Seismic data from Apollo-era experiments revealed a body that transmits vibration in an unexpected way. Rather than absorbing seismic energy as Earth does, the moon reflects and channels it. Some seismic waves appear to bounce within the interior, suggesting layered density variations or hollow regions, while later models proposed fractured rock and dry material as partial explanations. These models do not fully account for the duration and coherence of the recorded oscillations. A planet-sized object behaving acoustically like a resonant structure remains anomalous. Internal composition deepens the uncertainty. The moon's core is unusually small relative to its mass, yet it exhibits traces of magnetism that imply organized internal processes rather than geological exhaustion. Localized magnetic anomalies follow non-random distributions forming regions that correlate with gravitational irregularities. In natural systems, magnetism typically reflects chaotic thermal histories. On the moon, it appears constrained, patterned, and localized, as though governed by internal architecture rather than uniform decay. These findings intersect uncomfortably with the moon's orbital precision. Maintaining a stable orbit over immense spans of time requires exact initial conditions. Too much angular momentum and the moon would escape. Too little, and it would spiral inward. Even minor deviations would produce catastrophic tidal effects. The moon's present configuration sits within a narrow margin of stability that planetary scientists acknowledge but struggle to contextualize historically. The probability of achieving this configuration through chance formation is not zero, but it is vanishingly small. In engineering disciplines, when a system exhibits narrow tolerance, yet long-term stability, the assumption of deliberate calibration is routine. In astronomy, the same assumption is resisted not because it is unscientific, but because it challenges foundational expectations about the nature of cosmic processes. Yet resistance does not negate evidence. It merely delays interpretation. Ancient records complicate the picture further. Across disparate civilizations, the moon was treated not simply as a light in the sky, but as an agent. In Mesopotamian texts, it is described as a regulator of time and order. In Vedic literature, it appears as a vessel, something that moves with purpose rather than wandering aimlessly. Chinese astronomical chronicles speak of disruptions in celestial predictability, followed by the establishment of stable lunar cycles. These accounts do not read like mythic abstractions alone. They often describe transitional periods, adjustments, and learning curves as if observers were adapting to a new celestial condition. What is striking is the technical accuracy embedded within these narratives. Ancient astronomers tracked eclipses, nodal cycles, and long-term variations with a precision that would seem implausible without extended observation under changing conditions. Some records begin abruptly, as though reliable lunar prediction had a starting point rather than extending indefinitely into the past. This abruptness is difficult to reconcile with a moon that has orbited Earth unchanged for billions of years. Archaeology reinforces this tension. Early monumental structures focus overwhelmingly on solar alignment. Lunar complexity appears later, often layered onto existing sites. This pattern suggests not ignorance but sequence. Knowledge develops when conditions demand it. If lunar influence intensified or stabilized at a certain point, societies would respond accordingly, embedding new celestial mechanics into their cultural and architectural systems. At this juncture, speculation becomes unavoidable, but speculation need not be careless. One hypothesis, controversial yet persistent, proposes that the moon is artificial or partially engineered. In its mildest form, this hypothesis does not require a fully constructed object, but allows for modification, repositioning, or structural reinforcement. Even a naturally formed body could be altered, hollowed, or adjusted to serve a function. The scale is vast, but scale alone does not disqualify possibility. Human engineering already alters planetary systems in limited ways. Extrapolation across time and capability is not inherently illogical. If such intervention occurred, its purpose would likely be environmental rather than ornamental. The moon's effects align precisely with the requirements for long-term biological development: stable climate, moderated tides, predictable cycles, and gradual temporal pacing. These are not conveniences, they are prerequisites. The moon appears less like a decorative companion and more like a life support mechanism operating at planetary scale. This reframes the moon not as an anomaly, but as infrastructure. Infrastructure is often invisible precisely because it functions continuously and reliably. Only when it fails do its complexities become apparent. The moon has not failed. It has endured. Its reliability has made it easy to overlook its improbability. The implications of this perspective are unsettling. If the moon is engineered, then Earth's habitability may not be accidental. Life may not be merely an emergent property of chemistry, but the outcome of environmental preparation. This does not negate evolution. It reframes it. Evolution would remain the mechanism, but not necessarily the initiator. Conditions shape pathways. Provide a stable platform long enough and complexity will arise. Such a scenario does not require benevolence or malevolence. It requires only foresight. A system designed to produce complexity does not need to micromanage outcomes. It needs only to establish boundaries within which development can proceed. The moon does precisely that. Yet certainty remains elusive. Every anomaly admits alternative explanations. Fractured rock can mimic resonance. Gravitational interactions can stabilize orbits. Cultural memory can mythologize gradual change. Science advances by exhausting alternatives, not by embracing the most provocative hypothesis prematurely. But science also advances by refusing to ignore convergence. The moon sits at the convergence of physics, biology, history, and mathematics. Each field examined in isolation can explain fragments of its behavior. Together they outline a structure that appears less accidental than assumed. Whether this structure is the product of natural extremity or intentional design remains unresolved. Perhaps that unresolved state is itself meaningful. Some systems are meant to be stable long before they are understood. Some structures reveal their purpose only after their function has been fulfilled. The moon may belong to this category. It has already done what it needed to do. It has held Earth steady long enough for observers to arise. In that sense, the Moon does not demand belief. It demands patience. It continues its orbit without explanation, without announcement, without urgency. It allows inquiry to unfold slowly, constrained by evidence rather than imagination. Whatever its origin, the Moon remains a reminder that not all foundations are visible at first glance. Some mysteries persist because they are layered too deeply into reality to be extracted cleanly. The Moon may be one of those mysteries, not an answer waiting to be found, but a condition that made questioning possible in the first place. If the Moon's structure and influence suggest calibration rather than accident, then its silence becomes as significant as its presence. For an object so central to Earth's stability, the Moon offers remarkably little information about itself. It has no atmosphere to carry weather, no erosion to rewrite its surface quickly, no plate tectonics to recycle its crust. What happens on the Moon remains visible far longer than on Earth. Time behaves differently there. Impacts do not vanish, they accumulate. The Moon preserves history rather than renewing it. This preservation has often been treated as a limitation. In practice, it is a record. Lunar surfaces retain scars from epochs long erased on Earth. Yet even within this apparent openness, the Moon withholds. The far side unseen until the mid-20th century revealed a face profoundly unlike the one long familiar to humanity. Thicker crust, fewer smooth plains, an older, more battered surface. The asymmetry is not cosmetic. It reflects deep internal differences that remain poorly understood. If the Moon formed naturally from a disk of debris, uniformity would be expected. Debris does not sort itself neatly into hemispheric identities. Yet the Moon behaves as though it has an outward-facing side and an inward-facing one, a distinction that matters structurally as much as visually. The near side interacts continuously with Earth. The far side absorbs impacts, shields, and conceals. In engineered systems, such asymmetry is purposeful. Interfaces face users. Infrastructure faces away. Gravitational mapping has made this asymmetry harder to ignore. The Moon's mass is unevenly distributed with dense regions buried beneath its crust that affect spacecraft trajectories. These mascons behave like anchors, locking orbital behavior into stable patterns. They are concentrated in ways that correlate with major surface features, yet their density and coherence exceed what simple impact models predict. It is as though weight has been placed where weight is needed. These gravitational irregularities also shape the Moon's subtle wobble known as libration. Over time, libration allows observers on Earth to glimpse nearly 60% of the lunar surface despite its synchronous rotation. This effect has been essential to lunar mapping and long-term observation. The Moon reveals itself gradually, predictably, and completely, only to patient measurement. Random formation does not optimize observability. Systems do. The Moon's interaction with Earth extends below the surface as well. Tidal forces generate stress not only in oceans, but within Earth crust. These stresses influence volcanic activity, seismic cycles, and the redistribution of heat within the mantle. Over geological time, such influences shape continental movement and resource distribution. The Moon participates in Earth's internal evolution, not merely its surface dynamics. This participation raises an uncomfortable question: how many of Earth's defining features depend on lunar influence that we have assumed to be incidental? Remove the Moon, and Earth's history collapses into a different shape. The familiar narrative of gradual complexity may never begin. This dependence suggests not fragility, but contingency. Life here exists because conditions were held steady, long enough for complexity to unfold. Contingency is not proof of intention, but when contingency is layered upon improbability, improbability upon precision, and precision upon stability, the cumulative weight becomes difficult to dismiss. In scientific reasoning, convergence matters. Independent lines of evidence pointing toward the same implication deserve attention even if the implication is uncomfortable. One reason discomfort persists is scale. Engineering on lunar scale exceeds anything humanity has achieved. But scale alone is not an argument against possibility. Human structures once unimaginable now define landscapes. What matters is not current capability, but logical coherence. Could an intelligence capable of manipulating planetary systems exist? Physics does not forbid it. Energy requirements are vast but finite. Timescales are long but accessible to non-biological actors, or civilizations older than humanity by orders of magnitude. Another reason for resistance is psychological. Accepting that Earth's environment may have been prepared rather than accidental challenges deeply held assumptions about independence and randomness. It introduces the possibility that humanity developed within parameters set by forces outside itself. For many, this resembles loss of agency, yet agency is not diminished by context. Understanding conditions does not negate choice, it clarifies it. If the moon is a mechanism, it is a passive one. It does not intervene overtly, it does not communicate, it does not adjust itself visibly. It simply maintains conditions. Such restraint would be consistent with a long-term strategy aimed not at control, but at emergence. Intervene too directly, and development collapses into dependence. Intervene too little, and complexity never arises. The moon's influence sits precisely between these extremes. Silence in this context becomes deliberate. The moon does not announce its purpose. It allows observers to reach conclusions when they are ready. For most of human history, we lack the tools to question its nature seriously. Only recently have seismic data, orbital modelling, isotopic analysis, and historical cross-comparison made such questioning possible. The timing is notable. Recognition follows capability. This pattern mirrors developmental processes in biology and culture. Certain information becomes meaningful only after foundational structures are in place. Advanced concepts taught too early confuse rather than enlighten. If the moon functions as an enabling system, its deeper implications would naturally remain inaccessible until humanity develops sufficient analytical maturity. The absence of definitive answers may be a feature rather than a flaw. Systems designed to persist across immense timescales must accommodate uncertainty. They must allow observers to test hypotheses rather than receive declarations. The moon does not resolve its mystery because resolution is not required for function. At this stage, speculation about builders' motives or origins remains secondary. What matters is recognition of function. The moon stabilizes, it regulates, it preserves, it shapes time, water, and climate. These roles are measurable and undeniable. Whether they emerged accidentally or intentionally remains an open question, but the roles themselves are real. Perhaps the most unsettling realization is not that the moon might be artificial, but that Earth may not be self-sufficient. Our planet's apparent autonomy is supported by an external partner. Independence in this sense was always partial. Earth has always been in relationship shaped by forces beyond itself. Understanding that relationship does not diminish humanity. It situates it. Context is not confinement. It is orientation. The moon, whatever its origin, provides a reference frame against which Earth's history becomes legible. Some structures are so fundamental that they disappear into normality. We stop questioning gravity because it always works. We stop questioning the moon because it always rises. Yet permanence does not imply simplicity. Sometimes it indicates design that succeeded so completely it became invisible. The moon continues its orbit without comment, maintaining balances that rarely draw attention, precisely because they do not fail. Whether it is artifact or accident guardian or coincidence, it remains one of the most consequential objects in human existence. Its silence does not weaken the mystery, it deepens it. If the moon's silence conceals structure, then human memory becomes the next place to search for traces of disruption. Physical systems leave scars in rock and orbit, but cultural systems leave scars in story. Across civilizations separated by oceans and millennia, there are repeated claims that the sky was once different. These accounts are not uniform myths of creation. They are descriptions of change. They speak of adjustment, of learning of a world that had to relearn its rhythms. In Greek sources, references appear to peoples who lived before the moon. These passages are often dismissed as symbolic, yet they emerge from cultures with advanced astronomical traditions. Greek thinkers did not casually invent celestial claims. They inherited observations refined through Babylonian and Egyptian science. When writers like Plutarch mention a time without lunar cycles, they are preserving something older than philosophy, inherited memory filtered through rational culture. African oral histories offer similar anomalies. Among the Zulu and other group stories describe a sky altered by the arrival of a new light, accompanied by changes in tides, fertility and seasons. These narratives are not framed as divine spectacle alone, but as environmental disruption, followed by stabilization. The emphasis is not on wonder, but on consequence. Life had to adjust. Mesoamerican traditions introduce the moon not as eternal, but as assigned. Maya cosmology speaks of the moon being set in place after earlier worlds failed. While often interpreted metaphorically, the technical precision of Maya astronomy complicates that dismissal. These cultures tracked lunar cycles, eclipses, and long-term orbital patterns with extraordinary accuracy. Their myths coexist with mathematics. They are not ignorant poetry, they are layered records. Aboriginal Australian traditions, among the oldest continuous oral histories on Earth, describe the moon as a wanderer that eventually took its place in the sky. These accounts include detailed environmental changes, altered tides, new reproductive rhythms, different patterns of night illumination. Such specificity suggests observation rather than abstraction. Oral cultures preserve what matters. They do not retain unnecessary detail for tens of thousands of years. What unites these accounts is not a shared explanation, but a shared claim. The moon's presence was not always as it is now. If the moon has orbited Earth unchanged for over 4 billion years, such claim should not exist. Cultural memory does not reach that far. Either these stories are coordinated coincidence on a global scale, or they encode a disruption that occurred within the span of remembered human experience. Archaeology offers quiet corroboration. The earliest astronomical structures tend to prioritize solar alignment. Stone circles, earthworks, and monuments built in the deep past mark solstices and equinoxes with remarkable consistency. Lunar alignments, by contrast, often appear later. They are added, refined, or overlaid onto existing sites. This pattern implies adaptation rather than origin. Knowledge follows influence. Understanding the moon's complex cycles requires long-term observation. The 18.6-year nodal cycle, lunar standstills, and eclipse periodicities are not immediately apparent. They must be learned. Ancient societies invested enormous effort into this learning, suggesting that lunar behavior mattered practically, not symbolically. Calendars, agriculture, navigation, and ritual timing all depended on it. If lunar influence intensified or stabilized at a certain point, human systems would respond accordingly. Architecture would encode it. Timekeeping would adapt. Myth would preserve its arrival. This is precisely what the record suggests. The moon becomes central not gradually across all time, but abruptly across many cultures. From a scientific perspective, this raises uncomfortable questions about timing. The moon's recession rate implies a dynamic history, rather than eternal equilibrium. Orbital models allow for periods of instability followed by stabilization. If the moon's current configuration was achieved relatively recently in geological terms, its influence on Earth would have changed noticeably. Such change would leave cultural fingerprints. Biology shows parallel patterns. Rapid adaptation to lunar cycles across multiple species suggests strong selective pressure applied over a condensed timescale. Evolution does not require millions of years if environmental signals are intense. Sudden introduction of strong tides, illumination cycles, and gravitational rhythms would force rapid adjustment. The genetic record supports bursts of adaptation rather than uniform gradualism. Human biology is not exempt. Sleep patterns, reproductive timing, and behavioral rhythms show correlations with lunar phases. These correlations are inconsistent across modern populations, often weakened by artificial lighting and urbanization. Yet, in pre-industrial context, they appear stronger. This suggests not superstition but biological entrainment to an external regulator. If the moon's influence arrived, or intensified within the window of human evolution, the result would be precisely what we observe: widespread adaptation, cultural integration, and mythologized memory. The moon would not be remembered as an event, but as a transition. Not a single night of arrival, but a period of adjustment during which the sky learned its new order. This interpretation does not require assuming advanced builders or cosmic architects. It requires only accepting that the moon's history may be more complex than traditionally presented. A natural object could have been captured, repositioned, or altered by processes not yet fully understood. Alternatively, intervention may have occurred at scales we are not accustomed to considering. What matters is not the explanation chosen, but the willingness to acknowledge pattern. Science advances by recognizing when anomalies stop being noise and start being signal. The Moon produces such a signal across disciplines that rarely converge: orbital physics, geology, biology, archaeology, and myth. Skepticism remains essential. Extraordinary claims require extraordinary evidence, yet dismissal without engagement is not skepticism. It is avoidance. The Moon invites a more careful posture, one that neither leaps to conclusion nor retreats into comfort. Human history is filled with moments when foundational assumptions collapsed under accumulating detail. The Earth was not the centre. Continents were not fixed. Time was not young. Each revision expanded understanding rather than diminishing it. The Moon may represent another such threshold. If cultural memory preserves disruption and physical systems preserve calibration, then the Moon stands at an intersection of human and cosmic history. It is both a natural object and a historical actor. It changed Earth, and Earth changed because of it. Whether that change was accidental or intentional remains unresolved. But the record, scientific and cultural alike, suggests that the Moon's presence marks a turning point rather than a constant. It did not simply exist. It arrived into relevance. Some epochs are defined not by catastrophe, but by stabilization. Not by destruction, but by the quiet imposition of order. The Moon may represent such an epoch, a moment when chaos narrowed into corridor, when possibility hardened into pathway. If so, then the question is no longer merely where the Moon came from, but what it allowed to come into being. If the Moon marks a turning point rather than a constant, then it is necessary to consider its role within the broader pattern of planetary resets and environmental thresholds. Earth's history is not a smooth curve of progress. It is punctuated by abrupt transitions, ice ages, magnetic reversals, mass extinctions, and sudden radiations of life. These events are often treated as unrelated catastrophes, yet they share a common feature: they reshape conditions without erasing the underlying platform of habitability. The Moon's influence intersects with these transitions in subtle but persistent ways. Geological records show that tidal forces have not been constant through time. Sedimentary layers preserve rhythms of deposition that reflect ancient day lengths and tidal cycles. These records indicate that tides were once far stronger than they are today, and that Earth's rotation slowed rapidly during certain epochs. Such rapid deceleration cannot be explained by gradual processes alone. It suggests periods of intensified tidal interaction, as though the Earth-Moon system passed through phases of adjustment before settling into its present configuration. This adjustment period would have been disruptive, but not destructive. Stronger tides would have reshaped coastlines, flooded continental shelves, and created vast intertidal environments. These environments are not marginal. They are among the most biologically productive on the planet. They promote experimentation. Organisms repeatedly stressed by exposure and submersion adapt quickly or perish. Many biologists consider such zones crucial for the transition of life from sea to land. A newly stabilized or repositioned Moon would amplify exactly these conditions. The timing of major evolutionary leaps aligns intriguingly with periods of environmental instability followed by long-term calm. After each reset, complexity increases rather than collapses. This pattern is difficult to reconcile with a purely hostile universe. Resets clear pathways. They do not erase the destination. The Moon's stabilizing presence would be essential for ensuring that recovery leads forward rather than sideways. Climate modeling reinforces this view. Without the Moon's moderating influence, Earth's climate would swing unpredictably between extremes. Ice caps would advance and retreat chaotically. Equatorial regions would oscillate between drought and flood. Such volatility suppresses long-term biological planning. Stable climates allow specialization, symbiosis, and intelligence to emerge. The Moon enforces that stability not through rigidity, but through rhythmic moderation. These rhythms extend beyond climate into time itself. The lunar month became humanity's first natural calendar. Before writing, before agriculture, before cities, the moon provided a repeatable measure. Time became countable. Predictable cycles allowed memory to extend beyond immediate experience. Planning became possible. Cultural continuity emerged. The moon did not merely illuminate nights, it structured duration. This structuring effect may explain why early civilizations treated lunar observation as sacred rather than optional. Temples, monuments, and rituals aligned with lunar events are often dismissed as superstition, yet they reflect an intuitive recognition that the moon governed more than tides. It governed order. A world without stable cycles breeds anxiety. A world with cycles invites trust in recurrence. If the moon arrived into relevance during a period of planetary reset, its stabilizing influence would have been experienced as rescue rather than intrusion. Ancient stories describing chaos, followed by order, darkness, followed by rhythm, may encode precisely this transition. The moon would not be remembered as a foreign object, but as a solution. In this context, the idea of intervention need not imply control. It implies timing. Systems that aim to produce complexity often require periods of constraint following freedom. Too much freedom collapses into noise. Too much constraint collapses into stagnation. The moon's influence narrowed Earth's range of possibility into a productive corridor. That narrowing made evolution efficient. The question then becomes whether this narrowing was accidental. Planetary systems are chaotic, captures occur, resonances form, yet chaos rarely produces sustained harmony without continual disruption. The Earth-Moon system displays harmony across billions of years. Even its changes, recession, slowing rotation unfold gradually within safe bounds. That consistency resembles maintenance more than accident. Maintenance does not require constant intervention. It requires correct initial conditions. In engineering, a well-designed system runs quietly. Failures draw attention. Success fades into background. The moon's success as a stabilizer may be why its oddities have been tolerated rather than investigated aggressively. It works, therefore it is trusted. Yet trust is not understanding. The deeper the moon's influence is traced, the more it appears woven into Earth's biological and cultural architecture. This weaving extends into consciousness itself. Human cognition is attuned to cycles. Sleep, mood, creativity, and perception fluctuate rhythmically. While modern environments obscure these patterns, they remain detectable. The human mind expects recurrence. It anticipates return. This expectation may not be inherent. It may be learned under lunar conditions. A species that evolved without strong cyclical cues might conceptualize time linearly rather than rhythmically. Such a species would struggle to predict, to plan, or to imagine renewal. Human myths, philosophies, and sciences are saturated with cycles, birth and death, rise and fall, decay and return. These frameworks mirror lunar motion. The moon may have shaped not only biology but metaphysics. If so, then the moon's role in resets extends beyond geology into meaning. After disruption, it provides continuity. After collapse, it offers rhythm. Civilizations fall, but lunar cycles persist. Empires dissolve, but eclipses recur. This constancy may have anchored human identity through upheaval. The moon becomes a silent witness to resets not as cause but as stabilizer. This perspective reframes catastrophe itself. Not every reset is failure. Some are recalibration. The Earth has undergone multiple such recalibrations, each followed by greater complexity. The moon's presence ensures that recalibration does not exceed survivable limits. It constrains catastrophe into transformation. Whether this constraint emerged naturally or was imposed remains unresolved. But the pattern is clear. Earth's history is not random collapse punctuated by recovery. It is guided fluctuation within narrow tolerances. The moon defines those tolerances. At this point, speculation about builders or engineers becomes less important than recognizing system behavior. The moon functions as a boundary condition. It sets the stage upon which Earth's drama unfolds. Without it, the play does not proceed. Scientific caution demands restraint. No single anomaly proves design, but design is inferred not from singular features but from coherence across scales. The Moon's coherence, structural, orbital, biological, cultural, cannot be reduced easily to chance without stretching probability beyond comfort. Perhaps the most reasonable position is neither acceptance nor denial, but suspension. The Moon's role in Earth's resets and recoveries remains one of the most consequential unresolved questions in planetary science. Its influence is undeniable. Its origin remains opaque. In unresolved systems, function often precedes explanation. The Moon has already fulfilled its function. It has stabilized a world long enough for observers to ask how that stabilization occurred. Some questions arise only after survival is assured. The Moon ensured that assurance. Whether by accident or intention, it created a window in which inquiry itself could evolve. Earth passed through resets and emerged coherent. The Moon remained constant through them all. That constancy may be the most significant anomaly of all. If the Moon has acted as a stabilizer through Earth's resets, then its role can be understood as an echo rather than a command. It does not force outcomes, it resonates with them. Like a tuning fork struck once and left to vibrate, the Moon sustains patterns long after the initial impulse has faded. This quality of resonance may explain why its influence appears everywhere, yet announces itself nowhere. Echoes behave differently from causes. A cause is loud, disruptive, and brief. An echo is quiet, persistent, and shaping. Earth's major transitions, glacial retreats, biological irradiations, cultural awakenings often appear abrupt in the record, yet their aftermath unfolds slowly. The Moon's cycles provide a framework within which these aftermaths stabilize. It does not trigger resets, it makes recovery legible. This is visible in the way lunar rhythms synchronize disparate systems. Oceans respond first, then atmosphere, then biology, then behavior. The cascade is orderly. Each layer inherits rhythm from the one beneath it. Such inheritance suggests coupling rather than coincidence. When systems oscillate together, they exchange information. The Moon acts as a carrier of that information, translating gravitational motion into environmental regularity. Human history reflects this coupling. Periods of social collapse are often followed by renewed emphasis on calendars, astronomy, and ritual timing. After disorder, societies re-anchor themselves to cycles. They rebuild around predictability. The Moon becomes central again, not because it changed, but because attention returned to it. In this sense, lunar worship is less about reverence than about recalibration. The idea of echo also resolves a paradox in the Moon's mystery. If it were meant to dominate awareness, its influence would be obvious and overwhelming. If it were accidental, its effects would be inconsistent. Instead, it occupies a middle ground. Its presence is constant, its effects measurable, its purpose ambiguous. This ambiguity allows interpretation to evolve alongside understanding. From a scientific standpoint, echoes are signatures of structure. Sound echoes reveal chambers. Gravitational echoes reveal mass distributions. Cultural echoes reveal formative pressures. The Moon produces echoes across all three domains. Seismic waves linger. Orbits repeat with precision. Myths recur with similar motifs. These repetitions do not prove design, but they do indicate coherence. Coherence is the hallmark of systems that persist. Chaotic systems dissipate energy quickly. Coherent systems recycle it. The Moon recycles influence. Each orbit renews tides. Each phase renews light. Each eclipse renews alignment. Over time, renewal becomes expectation. Expectation becomes stability. This stability may be why the Moon feels ancient, even if its role evolved. Age is not only measured in years, but in integration. The Moon is integrated into Earth's processes so thoroughly that imagining their separation feels unnatural. That integration itself is evidence of long-term compatibility, whether achieved by chance or by constraint. The Moon's echo continues regardless of interpretation. It shapes night's waters and thought without demanding explanation. Perhaps that is its most enduring feature. It allows inquiry without urgency. It permits uncertainty without collapse. In the end, the Moon does not insist on meaning. It provides conditions. Meaning emerges within those conditions. Whatever its origin, the moon remains less a riddle to be solved than a structure to be recognized, one whose influence has already written itself into the deepest layers of Earth's history. Patterns begin to emerge most clearly when repetition spans domains that should not easily overlap. The moon appears in equations, in sediment, in myth, and in behavior, repeating itself in different languages, yet preserving the same underlying structure. This repetition is not loud, it is consistent, and consistency more than spectacle is what sustains systems across deep time. In physics, repetition appears as orbital regularity. The moon's path is predictable to an extraordinary degree, allowing its position to be calculated thousands of years backward and forward with minimal error. In geology, repetition appears as tidal layering in ancient rock formations marking days and months that no human ever witnessed. In biology, repetition manifests as synchronized life cycles species, separated by millions of years responding to the same gravitational cue. In culture, repetition takes the form of calendars, rituals, and myths that independently rediscover the same lunar truths. These repetitions suggest that the moon operates as a template rather than an event. Templates do not announce themselves. They persist quietly, shaping what passes through them. In this sense, the moon resembles other foundational systems that only become visible when removed. Gravity, atmospheric pressure, magnetic fields, all are largely invisible until they change. The moon belongs to this category of silent scaffolding. Scaffolding is temporary in construction but permanent in effect. Once a structure stands, the scaffolding disappears from attention. Earth's biosphere stands because conditions remained stable, long enough for complexity to take root. The moon may have been part of that scaffolding, whether natural or imposed, ensuring that fluctuations did not exceed survivable limits. If so, its success lies precisely in its invisibility. Human awareness tends to notice disruption rather than continuity. We remember catastrophes, not the long quiet between them. Yet it is in those quiet spans that intelligence accumulates. Language forms, tools refine, memory deepens. The moon presides over those spans without interference. It does not rescue civilizations. It allows them the time to rescue themselves. The archaeological record reinforces this interpretation. Advanced lunar knowledge does not appear where survival is most precarious, but where stability has already been achieved. Only when food systems are secure and populations settled do societies turn their attention skyward with precision. The moon becomes legible only when Earth is calm enough to observe it. In this way, lunar understanding is a byproduct of stability, not its cause. Yet once understood, lunar cycles feed back into stability. Agriculture improves, navigation becomes reliable, timekeeping enables coordination. The moon participates in a feedback loop. Stability enables observation. Observation enhances stability. This recursive relationship is characteristic of self-reinforcing systems. Such systems are robust. They resist collapse not by preventing change, but by absorbing it. Absorption rather than resistance may be the moon's most subtle function. When perturbations occur, asteroid impacts, climate shifts, biological crises, the moon remains unchanged. Its constancy provides a reference against which change can be measured. Without a reference, change is chaos. With a reference, it becomes information. This informational role extends into human cognition. The moon teaches comparison, light versus dark, growth versus decline, presence versus absence. These contrasts structure thought itself. Abstract reasoning depends on stable oppositions. Cycles train the mind to expect return to recognize phase rather than endpoint. A mind trained on cycles does not panic at endings. It anticipates transformation. If consciousness evolved under lunar influence, then cyclical thinking may be foundational rather than learned. This would explain why human cultures, regardless of geography, independently developed circular models of time. Linear time appears later, often tied to bureaucratic record-keeping and industrial scheduling. The older intuition is cyclic. The moon reinforces it nightly. None of this requires that the moon be artificial. Natural systems can also serve as templates. What matters is that the moon functions as one. Its presence compresses randomness into pattern. It reduces entropy locally by imposing rhythm. This does not violate thermodynamics, it redirects it. Redirection is the hallmark of intelligence, but also of natural constraint. Rivers channel water without intention. Mountains guide weather without awareness. The moon may be such a constraint, one whose scale magnifies its effect beyond intuitive comfort. The discomfort arises because the moon feels too well suited. It is easy to accept constraint when it is rough or limiting. It is harder to accept when it is enabling. The moon enables too many favourable conditions simultaneously to be ignored, yet too quietly to be celebrated. Perhaps the most responsible position is to treat the moon as a boundary condition whose origin remains open. Its role is observable, its necessity is measurable, its history is incomplete. That incompleteness is not failure of knowledge, but invitation to patience. Patterns that persist across physics, life, and culture are rarely trivial. They deserve attention even when explanation lags. The moon has earned that attention not by spectacle, but by endurance. Whatever shaped its chance constraint or intention, the moon continues to hold Earth within a narrow life-permitting corridor. That fact alone places it among the most consequential features of our world. Understanding may come later. For now, recognition is sufficient. At the edge of all these patterns lies a final tension that science has not yet resolved: the distinction between explanation and acceptance. Many phenomena are understood well enough to function within models, yet not well enough to feel settled. The moon belongs firmly in this category. Its effects are measurable, its behaviour predictable, its presence indispensable, and yet its origin remains uncomfortably resistant to closure. This resistance is not a failure of inquiry, it is a signal. In the history of science, the most transformative insights often emerge not from anomalies themselves, but from the refusal to dismiss them once they accumulated beyond convenience. Continental drift lingered for decades as an embarrassment. Meteor impacts were once ridiculed as catastrophism. The deep age of Earth conflicted with doctrine before it redefined time itself. Each shift began with recognition that existing explanations, while functional, were incomplete. The moon now occupies a similar threshold. The giant impact hypothesis explains some observations elegantly, yet leaves others unresolved. Orbital precision, internal resonance, hemispheric asymmetry, biological synchronization, cultural memory, each is addressed partially, never fully. The result is a patchwork of explanations that function locally, but strain collectively. Such strain does not demand immediate replacement. It demands attention. Attention changes posture. Instead of asking how quickly a mystery can be closed, attention asks what the mystery is doing. The moon does not merely exist as an object of study. It operates as an active constraint on Earth's possibilities. It narrows chaos into rhythm violence, into tide randomness, into repetition. These operations are ongoing. They are not historical curiosities. They continue every day. This continuity suggests that the moon's most important role may not be behind us, but still unfolding. Stabilization is not a single act. It is a process maintained over time. Earth remains vulnerable to disruption, asteroids, climate shifts, internal instabilities. The moon continues to moderate, absorb, and regulate. It does so without adjustment, without feedback, without visible intervention. Its effectiveness lies in its constancy. Constancy often goes unnoticed until it fails. Power grids, ecosystems, and social norms draw attention only when disrupted. The moon has never failed in human memory. That uninterrupted performance may be why its deeper implications remain unexamined outside specialized fields. Reliability breeds complacency, yet reliability on cosmic timescales is itself anomalous. There is also a philosophical consequence to recognizing the moon as foundational rather than incidental. It reframes humanity's relationship to its environment. Instead of imagining life as a fragile accident clinging to chance, it suggests life arose within constraints that favored persistence. Constraint does not eliminate freedom. It enables it. A riverbed constrains water, yet allows flow. Without the bed, there is no river. This perspective does not require abandoning skepticism. It refines it. True skepticism does not reject unsettling possibilities reflexively. It tests them patiently. It allows questions to remain open when closure would be premature. The Moon invites this kind of skepticism, measured, disciplined, and attentive to convergence rather than novelty. What remains striking is how often the Moon disappears from conversations about habitability. Discussions of exoplanets focus on distance from stars' atmospheric composition and magnetic fields. Rarely is the presence of a large stabilizing moon considered central. Yet on Earth, it is precisely such a moon that moderates climate structures time and supports biological complexity. This omission may reflect assumption rather than evidence. If future observations reveal Earth like planets, without large moons to be rare or unstable, the Moon's role will move from curiosity to criterion. Habitability may require not only the right planet but the right partner. If so, the Moon will emerge not as a footnote but as a defining feature. Until then, the Moon remains what it has always been present, influential and unresolved. It does not demand interpretation. It allows it. It offers no message yet structures meaning. It does not explain itself yet makes explanation possible. Some foundations are not meant to be obvious. They operate best when unnoticed, supporting complexity quietly, until complexity learns to look down rather than up. Humanity may be approaching that moment now, not because the Moon has changed, but because observation has matured. Whether the Moon is artifact accident or hybrid of both its role is already written into Earth's story. Oceans, climates, organisms, and cultures bear its imprint. The question of who built the Moon may remain unanswered. But the question of why it matters no longer does. It matters because it holds the world steady, and in doing so it holds open the space in which understanding can continue to grow. The unresolved nature of the Moon's origin does not weaken its significance. In many ways it strengthens it. Systems that are fully explained often fade into abstraction, reduced to equations and diagrams. Systems that remain partially unexplained retain presence. They continue to exert intellectual gravity. The Moon belongs to this second category. It is both understood and unfinished a structure, whose function is clearer than its history. This distinction matters. In science, origin, stories are often privileged over operational roles, yet it is function that shapes outcomes. The Moon's function has been constant for as long as complex life has existed on Earth. It stabilizes axial tilt, regulates tides, moderates rotation, and structures time. These effects are cumulative. Remove any one of them and Earth's evolutionary trajectory diverges sharply. Remove all of them and the familiar biosphere never emerges. What makes this remarkable is not simply that the Moon performs these roles, but that it performs them within narrow margins. The Earth-Moon distance is neither too close nor too far. The mass ratio is neither too small to be ineffective nor too large to induce catastrophic tides. The orbital inclination avoids extreme perturbations while still allowing measurable variation. Each parameter lies within a window that supports long-term continuity. These windows are mathematically describable, yet their overlap is improbable. In complex systems, analysis such overlap often indicates constraint rather than coincidence. When independent variables converge on a stable regime, the system is either exceptionally lucky or shaped by limiting conditions. Physics does not prohibit exceptional luck, but neither does it require assuming it. The Moon's configuration sits precisely at this intersection, possible by chance, persuasive by pattern. The reluctance to explore this intersection openly reflects more than scientific caution. It reflects historical memory. Past attempts to attribute cosmic structure to purpose were often entangled with dogma. Modern science reacted by emphasizing randomness and blind process. That correction was necessary. But corrections can overshoot. In avoiding purpose inquiry may have sidelined legitimate questions about constraint optimization and long-term stability. Optimization is not mysticism. It is a measurable property of systems. Rivers optimize flow. Crystals optimize lattice energy. Biological structures optimize survival within environments. The Moon appears optimized for Earth, not in isolation, but in relationship. Its properties make sense when considered as part of a coupled system rather than as an independent object. This relational view dissolves some of the tension between natural and artificial explanations. A system can be natural and constrained without being constructed. It can also be constructed using natural processes. These categories are not mutually exclusive. The insistence on choosing one prematurely obscures the more interesting question: how did such a stable relationship arise and persist? Persistence is often overlooked. Many planetary systems are unstable over long timescales. Orbits shift, resonances break, moons are lost or destroyed. The Earth-Moon system has endured through asteroid bombardment, planetary migration, solar evolution, and internal geological upheaval. Its endurance suggests robustness. Robust systems are not fragile. They tolerate disturbance without collapse. This robustness has consequences for life. Stability allows accumulation. Genetic information builds gradually. Ecosystems layer complexity. Intelligence emerges slowly. None of these processes tolerate frequent systemic disruption. The Moon's constancy provides a background against which variability becomes informative rather than destructive. It sets the tempo at which change can occur. Tempo is a subtle but crucial concept. Too fast and adaptation fails. Too slow and stagnation dominates. The Moon moderates tempo by slowing Earth's rotation and regulating cycles. It stretches time just enough for complexity to keep pace. This stretching may be one of its most consequential effects. It gave Earth time. Time is often treated as an external parameter, yet it is shaped by physical systems. Day length, season length, and rhythmic recurrence influence perception, memory, and planning. A species evolving under rapidly changing temporal conditions would develop differently from one under steady rhythms. Human cognition reflects patience, anticipation, and long-term projection traits nurtured by predictable cycles. This cognitive dimension closes a loop. The Moon may have shaped not only the conditions for life, but the conditions for reflection. Intelligence capable of asking about origins requires stability, not just of environment, but of experience. Memory requires repetition. Meaning requires pattern. The Moon provides both. At this point, the question of who built the Moon becomes less central than the question of what kind of universe permits such structures to exist. A universe that allows long-term, stable constraints capable of nurturing complexity is not hostile to life. It may be indifferent, but indifference does not preclude structure. Order can arise without intention, yet intention can also operate through order. Distinguishing between these possibilities may ultimately prove impossible. Evidence erodes over deep time. Builders, if any existed, would leave no obvious signatures after billions of years. Natural processes given enough time can mimic design convincingly. The Moon may sit beyond definitive classification, but classification is not the only goal of inquiry. Understanding role function and consequence is equally valuable. On these fronts, the Moon is no longer obscure. Its role is central. Its function is measurable. Its consequences are written into oceans, climates, genomes, and calendars. Humanity may never know the Moon's full history. That ignorance does not diminish its significance. Some foundations are meant to be inferred rather than excavated. They reveal themselves through what they support, not through what they declare. The Moon continues its orbit unchanged by our questions. It does not answer. It does not respond. It simply persists, holding Earth within tolerances that allow inquiry itself to continue. In that sense, the Moon is not merely an object of mystery. It is a condition for mystery. Whatever shaped it, chance, constraint, or design, it succeeded. Earth remained stable. Life endured. Observers arose. That outcome alone warrants attention. And as long as the Moon remains in the sky maintaining its quiet work, the question of its origin will remain open, not as a failure of a knowledge, but as a reminder that some of the most important structures in existence are not those we fully understand, but those that quietly make understanding possible. The question that remains, after all evidence is considered, is not whether the Moon is mysterious, but whether mystery itself is an acceptable scientific endpoint. Modern inquiry is trained to resolve to reduce uncertainty to close loops. Yet some structures resist closure, not because they are poorly understood, but because they are foundational. Removing them from uncertainty would require removing the very framework that allows inquiry to exist. The Moon may be such a structure. It is embedded so deeply into Earth's physical, biological, and cognitive systems that separating cause from consequence becomes increasingly difficult. Did life adapt to the moon, or did the moon shape the conditions under which adaptation could occur at all? Did human culture mythologize the moon because it was central, or did it become central because it stabilized the rhythms culture depends on? These questions fold back on themselves, producing not contradiction, but interdependence. Scientific progress often advances through isolation, controlling variables, separating systems, reducing complexity. But some systems cannot be meaningfully isolated. The Earth-Moon relationship is one of them. Remove the Moon, and Earth is no longer the same experimental subject. It becomes another planet entirely. Any attempt to understand Earth without the Moon becomes hypothetical rather than explanatory. This realization shifts the posture of inquiry. Instead of asking how the Moon formed in isolation, the more productive question becomes how the Earth-Moon system behaves as a whole. When examined this way, the system displays properties that neither body exhibits: alone long-term climate stability, slow rotational pacing, synchronized biological rhythms, and persistent environmental memory. These emergent properties define Earth as a living world rather than a geological object. Emergence complicates origin stories. Systems that exhibit emergent behavior cannot be fully understood by tracing components backward in time. Their significance lies in interaction rather than ancestry. Whether the Moon formed through impact, capture modification, or some hybrid process, its present role arises from coupling rather than creation. This perspective does not resolve the mystery. It reframes it. The Moon's origin becomes less urgent than its persistence. Why did this system endure when so many others did not? Why did perturbations fail to destabilize it? Why did its influence remain beneficial rather than destructive? One answer may lie in feedback. Stable systems regulate deviation. The Moon provides negative feedback to Earth's axial tilt rotation and tides. When extremes threaten, the system resists. Feedback loops are hallmarks of systems that maintain equilibrium over long periods. In cybernetics, ecology, and engineering, such loops are rarely accidental. They arise through selection, either natural or imposed of configurations that survive. Selection need not imply consciousness. Natural systems select for stability through elimination of unstable configurations. Over time, only robust arrangements persist. The Earth-Moon system may simply be one of the few arrangements that survived long enough to be noticed. Yet survival at this scale requires extraordinary alignment. Billions of failed configurations would leave no trace. We observe the survivor because it survived. This survivor bias does not invalidate the Moon's anomaly, it contextualizes it. The Moon may not be unique because it was designed, but because only systems like it allow observers to exist. This line of reasoning echoes anthropic arguments in cosmology. Yet even anthropic explanations do not erase the need to understand how such systems form. The Moon remains difficult to place within a purely random narratives. Randomness produces variation. Selection produces constraint. The Moon exhibits constraint far more than variation. Its orbit tightens rather than destabilizes. Its influence narrows rather than amplifies extremes. These characteristics align with long-term viability, not short-term chaos. Human civilization arose within this viability window. Writing, science, and reflection all require extended periods of environmental predictability. Collapse interrupts memory. Stability preserves it. The Moon's contribution to stability may therefore underwrite not only biology, but knowledge itself. Without it, there may have been no continuous thread long enough to weave understanding. This introduces a humbling possibility. Humanity may not be the first intelligence shaped by such constraints. If the Moon is part of a broader class of stabilizing structures, then similar systems elsewhere might also produce observers who ask similar questions. The Moon would then represent not uniqueness, but pattern a recurring solution to a universal problem: how to keep a world coherent long enough for complexity to awaken. If this is the case, then the Moon's mystery expands beyond Earth. It becomes a clue to habitability at large. Worlds capable of sustaining intelligence may require more than the right distance from a star. They may require partners objects that regulate, moderate, and stabilize across deep time. Such partners would be quiet by necessity. Loud systems disrupt. Silent systems endure. The Moon's silence may therefore be functional. It does not draw attention because attention is not required for it to work. Only after intelligence arises does silence become noticeable. At that point, silence invites interpretation. Interpretation, however, must remain disciplined. There is no evidence that the moon communicates, adjusts, or responds. It does not guide civilization. It does not intervene. It does not signal intent. It simply maintains conditions. Any meaning attributed beyond that remains speculative. Yet speculation has always accompanied frontier questions. Before atoms were confirmed, they were speculated. Before continents moved, they were imagined. Before time stretched billions of years, it was conjectured. Speculation becomes science when constrained by evidence rather than fantasy. The moon constrained speculation tightly. Its measurable effects bound interpretation. What emerges from this bounded speculation is not certainty but coherence. The moon coheres with Earth in the ways that matter. Its presence is not decorative, it is structural. Whether by chance filtered through selection or by intention, expressed through natural law, the outcome is the same, a stable platform for life and thought. The moon may never yield a definitive answer to the question of who built it, if anyone did. But it answers a more fundamental question continuously without interruption. Can complexity persist? For over 4 billion years, the answer has been yes. That persistence is the moon's legacy, not as an object to be explained away, but as a condition that allowed explanation to emerge at all. At the far end of this inquiry lies a quiet realization. The moon does not ask to be believed. It does not require acceptance of any single explanation to continue doing what it has always done. It stabilizes, moderates, and endures regardless of how humans interpret its presence. In this way, the moon stands apart from most scientific controversies. It is not a claim waiting to be defended, but a condition already fulfilled. What unsettles inquiry is not the moon's mystery, but its normality. It has become so familiar that its improbability feels invisible. Night after night it rises on schedule. Month after month its phases repeat. Year after year, tides obey its pull. This repetition dulls curiosity. Yet repetition is precisely what makes the moon exceptional. Few cosmic systems maintain such regularity across such immense spans of time. When examined without assumption, the moon appears less like a leftover fragment of chaos, and more like a boundary marker. It defines limits: how fast Earth spins, how far its axis may wander, how violently its oceans may move. These limits are not arbitrary. They sit at thresholds that permit continuity. Below them, stagnation threatens. Above them, instability dominates. The moon holds Earth between these extremes. This balancing act does not resemble the aftermath of an accident. Accidents produce irregular outcomes. Balance suggests either extraordinary selection or deliberate constraint. Science can accommodate the former comfortably. It struggles with the latter not because it is impossible, but because it lies outside traditional explanatory habits. Yet explanatory habits evolve when evidence demands it. What is increasingly clear is that the moon cannot be treated as a secondary detail in Earth's story. It is not merely present, it is participatory. Remove it from equations and models break. Remove it from history and continuity dissolves. Remove it from biology and rhythms fragment. The moon's involvement is systemic. This systemic involvement invites a shift in perspective. Instead of asking whether the moon was built, it may be more productive to ask what kind of processes can generate structures that behave as if they were built. Nature is capable of producing astonishing order under constraint. Snowflakes, crystal lattices, and planetary rings exhibit structure without intention. At the same time, intelligence, when it arises, often works through constraint rather than force. It leverages existing processes rather than overriding them. The moon could belong to either category, or to a region where the categories overlap. A naturally formed body could be selected, captured, or modified to serve a stabilizing role. Such modification would not need to be visible after billions of years. It would need only to set initial conditions correctly. Once established, natural laws would do the rest. This possibility remains speculative, but it is bounded by evidence rather than fantasy. The moon's properties constrains speculation tightly. Any viable explanation must account for orbital precision, internal structure, hemispheric asymmetry, long-term stability, and biological synchronization. Few hypotheses address all of these simultaneously. None do so conclusively. Yet, lack of conclusion does not imply lack of progress. Sometimes progress consists of recognizing that a system is more integrated than previously assumed. The Earth-Moon system appears to be such a case. Earth is not merely a planet with a moon. It is part of a coupled pair whose dynamics cannot be disentangled without losing explanatory power. This coupling may extend beyond physics into cognition. Human thought evolved within lunar rhythms. Memory planning and anticipation depend on predictable cycles. The moon may have trained perception itself, teaching minds to expect return rather than finality. Such training would have profound consequences for culture, philosophy, and science. It would favour inquiry over reaction, patience over immediacy. If intelligence is nurtured by stability, then the moon indirectly nurtured intelligence. This does not elevate the moon to agency. It acknowledges its influence. Influence does not require intention to be meaningful. It requires effect. The moon's effects are indisputable. The broader implication is sobering. Earth's apparent autonomy may be an illusion. Our planet's habitability may depend on relationships beyond itself. If so, then searching for life elsewhere requires expanding criteria. Worlds may need not only stars and atmospheres, but companions, objects that regulate rather than disrupt, that persist rather than fluctuate. This reframing does not diminish humanity. It situates it within a larger architecture, understanding that architecture is not an admission of insignificance, it is an expansion of context. Context does not erase agency, it clarifies the conditions under which agency arose. The moon remains silent on these matters. It offers no confirmation, no denial. It continues its orbit indifferent to interpretation. That indifference may be the most honest feature of all. Truth does not need endorsement. It persists whether recognized or not. In the end, the moon's greatest contribution may not be what it reveals, but what it makes possible. It held Earth steady long enough for oceans to organize, for life to diversify, for minds to emerge, and for questions to be asked. That sequence is not trivial. It is rare. Whether by chance filtered through vast time or by constraint imposed at the beginning, the outcome converges on the same result, a world capable of reflection. The moon does not explain itself. It does not need to. Its role is already written into the deep structure of existence on this planet. It remains overhead, constant and unresolved, a reminder that some of the most important elements of reality are not those we fully understand, but those that quietly allow understanding to exist at all. And as long as the moon continues its unbroken orbit, the question of its origin will remain open, not as a flaw in knowledge, but as an invitation to humility before systems larger, older, and more stable than our explanations. By the time inquiry reaches this stage, the question of the moon's origin begins to dissolve into something more subtle. The issue is no longer whether it is natural or artificial, ancient or recent, accidental or arranged. What emerges instead is a recognition that the moon functions as a boundary condition for Earth itself. It is not simply an object in orbit, but a regulating presence that defines what Earth can become. Geologically, the moon acts as a stabilizer that Earth could not replace on its own. Without it, axial tilt would wander chaotically under the gravitational influence of other planets. Such wandering would produce extreme climatic swings, erasing the long stable periods required for complex ecosystems to take root. Ice ages would arrive without warning. Tropical belts would migrate unpredictably. Evolution would be forced into constant reaction rather than gradual adaptation. The moon suppresses this chaos not by force but by mass placed at the correct distance, exerting a steady corrective influence. This role extends downward into Earth's interior. Tidal forces generated by the moon do not only move oceans, they flex the planet itself. That flexing contributes to geothermal activity, keeping tectonic systems active over billions of years. Plate tectonics recycle nutrients, regulate atmospheric gases, and prevent the planet from becoming geologically inert. A world without internal renewal becomes sterile. In this sense, the moon is part of Earth's metabolic system. Biology reflects this dependency with remarkable clarity. The earliest life evolved in tidal zones where periodic exposure and immersion created natural laboratories for chemical complexity. These environments depend on strong regular tides. Weak tides would have produced uniformity. Excessive tides would have destroyed nascent structures. The Moon again occupies the narrow middle ground where variation exists without catastrophe. This balance repeats across scales from microbes to mammals. Human history carries quieter traces of the same influence. Long before formal astronomy, lunar cycles shaped calendars, agriculture and ritual. Time itself became divisible and predictable because the Moon offered a visible rhythm. This mattered profoundly. Predictability allows memory to extend forward. Planning expectation and deferred action depend on cycles that repeat reliably. The Moon trained cognition to operate within time rather than merely react to environment. The persistence of lunar symbolism across cultures reflects this training. The Moon appears not as a god of destruction, but of order, return and measurement. Even when feared, it is feared for its power to alter states gradually rather than suddenly. Eclipses were alarming not because they destroyed the sun, but because they momentarily violated an expected pattern. Pattern violation implies an underlying rule. The Moon taught humanity to assume that rules exist. From this perspective, the Moon's most significant contribution may be epistemological. It conditioned minds to look for structure rather than randomness. That conditioning is foundational to science itself. The assumption that nature follows discoverable laws is not obvious in a chaotic world. It becomes obvious only in a world where large-scale phenomena behave consistently. The Moon provided one of the first demonstrations of such consistency. This realization reframes the artificial moon hypothesis in a more restrained light. Even if the Moon were entirely natural, its effects resemble those of an engineered system, because engineering often seeks the same outcomes: stability, reliability, and scalability. An engineer designs systems that maintain function despite perturbation. The Earth-Moon system exhibits precisely this resilience. External forces act upon it, yet it remains within habitable bounds. The difference between design and selection becomes less distinct at cosmic scales. Natural selection can produce outcomes that appear designed if the filtering process is sufficiently strict. A system that fails disappears. A system that persists accumulates history. The Moon's persistence may reflect extreme filtering rather than intention, but extreme filtering itself demands explanation. What processes allow such filtering to occur repeatedly without collapse? This question leads beyond the Moon toward a broader cosmological implication. Habitability may not be a local property of planets alone. It may emerge from multi-body systems arranged within narrow tolerances. If so, then Earth's apparent isolation is misleading. Its stability is distributed across space shared with a companion whose presence is as critical as Earth's own mass and composition. The rarity of such arrangements would explain the apparent silence of the universe. Life may not be rare because chemistry fails, but because architecture does. Worlds capable of sustaining intelligence may require configurations that are statistically uncommon. A planet, a star, and a companion locked into long-term equilibrium may be the exception rather than the rule. This possibility does not require invoking external builders. It requires accepting that complexity arises not merely from components, but from relationships. The Moon is defined less by what it is than by what it does in relation to Earth. Its identity is relational rather than intrinsic. Remove the Earth, and the Moon loses meaning. Remove the Moon, and Earth loses continuity. In this sense, the Moon functions as a constraint that made freedom possible. By limiting extremes, it allowed exploration within boundaries. Life could experiment because conditions remained survivable. Intelligence could emerge because environments remained legible. Culture could develop because time itself remained structured. The unresolved nature of the Moon's origin does not weaken this conclusion. It strengthens it. Systems that matter most often resist simple explanation because they operate across domains. Physics, geology, biology, and cognition intersect here. No single discipline can claim ownership of the answer. What remains is a quiet shift in attitude. Instead of treating the Moon as an object to be explained away, it can be approached as a partner in Earth's history. Not a conscious partner, but a functional one. Its silence is not emptiness, but endurance. The question of who built the Moon may never be resolved in the way some expect, but the question of what the Moon has built is already answered. It shaped a world capable of asking questions at all. That fact alone places the moon among the most consequential features of human existence, not because it demands belief, but because it made belief inquiry and understanding possible. As inquiry moves toward its final threshold, the moon ceases to function merely as evidence and begins to operate as context. Its anomalies no longer stand apart as curiosities to be listed or dismissed. Instead, they converge into a single implication. Whatever the moon's origin, its continued presence represents a long-term intervention in Earth's trajectory. Not an intrusion, but a sustained condition that reshaped probability itself. Probability governs cosmic evolution more than intention ever could. Stars ignite or fail. Planets coalesce or scatter. Orbits destabilize. Most arrangements do not last. Against this background, the Earth-Moon system appears less like a random snapshot, and more like an outcome that survived an extraordinary number of elimination filters. Each epoch tested it. Each perturbation threatened collapse. Yet the system endured, retaining the narrow parameters that allow oceans to circulate climates, to stabilize, and biospheres to complexify. This endurance has consequences that extend beyond physical survival. Stability allows accumulation. Accumulation allows memory. Memory allows history. Without long-term stability, intelligence may arise briefly only to be erased before it can reflect on its own emergence. The moon's greatest contribution may therefore be temporal rather than spatial. It gave Earth time. Time, however, is not passive. Over long spans, it amplifies small effects. Tidal friction lengthened Earth's day. A shorter day would have meant stronger winds, harsher weather systems, and greater atmospheric loss. As rotation slowed, nights lengthened, allowing deeper thermal gradients and more complex ecological niches. Even circadian rhythms trace their roots to this gradual deceleration. The moon altered the tempo of life without ever touching it directly. This slow modulation stands in contrast to catastrophic explanations often favoured in speculative narratives. There is no single moment when the moon activated Earth. No abrupt switch. Instead, its influence accumulated through repetition. Each tide reinforced the last. Each orbit reaffirmed the same geometry. This kind of influence is difficult to detect because it leaves no singular scar. It leaves only a world that behaves differently than it otherwise would have. Human perception struggles with such causality. Minds evolve to notice sudden change, not persistent constraint. As a result, the moon feels familiar, almost invisible. Familiarity breeds assumption. Assumption breeds neglect. Yet when removed from thought experiments, its absence reveals how tightly woven it is into nearly every system that matters. This realization shifts the debate away from origins and toward responsibility. If Earth's habitability depends on a relational architecture, rather than isolated factors, then altering the architecture carries risk. Human plans for large-scale lunar exploitation often assume the moon is inert a resource bank rather than a regulator. But regulators do not announce themselves. Their effects appear only when disrupted. Extracting mass-altering albedo or modifying orbital parameters even slightly could have consequences that unfold over centuries rather than years. Such consequences would evade political cycles and technological optimism alike. They would manifest quietly through altered tides, subtle climatic drift, or changes in Earth's rotational balance. The moon's silence does not imply indifference. It implies scale. Scale also reframes the search for extraterrestrial intelligence. The absence of obvious signals may reflect not a lack of intelligence, but a preference for durability over display. Systems designed to persist would minimize detectable output. They would integrate rather than broadcast. If intelligence exists elsewhere and operates at planetary scales, its traces may resemble natural features precisely because natural selection would favor designs that blend into cosmic background noise. Under this interpretation, the moon does not need to be artificial to be instructive. It demonstrates what matters most for long-term complexity, moderation, repetition, and relational balance. Whether these qualities arose through chance or choice becomes secondary to their effect. The universe may produce intelligence not through singular miracles, but through rare alignments that sustain learning long enough for self-awareness to emerge. Self-awareness introduces a final complication. Once a system becomes conscious of its dependencies, it acquires ethical weight. Humanity now understands that its survival is entangled with factors far beyond atmosphere and geology. The Moon is no longer merely an object of study. It is part of a shared system whose maintenance exceeds any single generation's horizon. This awareness does not require reverence, nor does it demand fear. It demands restraint. Scientific maturity is measured not only by what can be done, but by what should remain untouched. The Moon has already done its work without instruction. Interfering without full comprehension risks unravelling conditions that cannot be restored once lost. The enduring mystery of the Moon thus serves a practical function. It resists closure. It prevents complacency. As long as its origin remains uncertain, it invites humility. Humility in turn tempers ambition. In this way, the Moon continues to shape human behaviour, even as technological capacity grows. The question of who built the Moon may never receive a definitive answer, but the question of whether humanity can coexist responsibly with the systems that enabled its emergence remains open. That question is no longer astronomical. It is philosophical, ecological, and civilizational. In the end, the Moon does not demand belief. It demands attention. Not the kind that seeks to conquer or explain away, but the kind that recognizes dependence without fully grasping its depth. Such recognition marks the transition from a species that inhabits a world to one that understands it, lives within a delicate architecture. The Moon remains overhead, unchanged, in appearance indifferent to interpretation. Yet its influence persists, measured not in spectacle but in continuity, a quiet constant in a universe defined by impermanence. Whether born of chance or arrangement, it has fulfilled the same role for billions of years. That role is not to illuminate the night, but to make the night survivable, long enough for intelligence to arise and ask why light exists at all. The Moon remains above Earth without commentary, without signal, without explanation. It does not announce its origin, defend its anomalies, or resolve the debates it inspires. Instead, it persists, and persistence at planetary scale is a form of evidence. Across human history, the Moon has served as a silent reference point, against which change could be measured. Civilizations rose and fell beneath it, yet its motion remained steady enough to anchor calendars, navigation, agriculture, and ritual. This constancy shaped how humanity learned to think about time itself. Time became something cyclical, predictable, and therefore meaningful. Without such regularity, history would fracture into disconnected moments incapable of accumulation. Scientific inquiry now stands at a similar threshold. The Moon's unresolved questions are no longer barriers to knowledge but indicators of scale. Systems that operate across billions of years do not yield simple answers. They reveal themselves through influence rather than confession. The Moon's influence is written into Earth's tides' axial stability, biological rhythms, and climatic moderation. Remove any one of these effects and the story of life alters beyond recognition. Whether these outcomes emerge through improbable coincidence or deliberate arrangement may remain permanently uncertain. Yet uncertainty does not diminish consequence. A bridge does not need to be understood by its users to carry weight. It only needs to hold. The Moon has held Earth in equilibrium long enough for intelligence to appear reflect and question its own foundations. This recognition introduces responsibility. Humanity has reached a stage where it can alter celestial bodies rather than merely observe them. Lunar mining, orbital modification, and permanent settlement are no longer speculative fantasies. They are engineering problems awaiting political will. But engineering without systemic understanding risks destabilizing conditions whose importance only becomes visible after loss. The Moon's greatest lesson may therefore be restraint. It demonstrates that power exercised subtly, repeatedly, and patiently can shape worlds more effectively than force. Its influence accumulates quietly, tide by tide, orbit by orbit. No single moment reveals its importance. Only absence would. There is a temptation to frame the Moon as either miracle or machine artifact or accident. Both extremes simplify a reality that resists simplification. What matters is not classification, but relationship. Earth and Moon form a coupled system whose properties emerge only together. Separating them conceptually obscures the truth that habitability is not a planetary trait but a shared condition. As humanity looks outward, searching for life among distant stars, the Moon offers a cautionary model. Life may depend less on isolated planets and more on long-term architectural balance. Intelligence may arise not where conditions are merely favourable, but where they remain stable, long enough for memory learning and culture to compound. The Moon does not promise answers about builders' intentions or cosmic design. What it provides instead is continuity, a demonstration that complexity requires patience, that survival depends on balance, and that the most consequential forces are often the least dramatic. In the end, the Moon's silence is appropriate. It has already spoken through ocean, stone climate, and consciousness. Its message was never verbal. It was structural. It shaped a world capable of asking questions and living long enough to tolerate uncertainty. That tolerance may be humanity's final inheritance. Not the knowledge of who placed the Moon in the sky, but the wisdom to recognize that some systems must be preserved even when their origins remain unknown. Beneath its familiar light, the task is no longer to solve the Moon, but to remain worthy of the stability it provides. Such awareness defines maturity, survival, and responsibility within a universe that rewards balance over ambition and patience. We've reached the quiet edge of tonight's journey, traveller. The questions we followed have grown softer now, like footprints fading in lunar dust. We walk through calculations and ancient memory, through silence that rings, and shadows that hold their shape. And here at the end, the Moon remains exactly where it has always been, untroubled by our curiosity, unchanged by our wondering. The universe does not hurry to explain itself. It allows mystery to remain not as a failure of knowledge, but as a form of balance. Some truths are too large to arrive all at once. They unfold slowly across centuries, across generations sometimes, across an entire species learning how to look without needing to claim ownership. The Moon continues its long orbit, shaping tides, steadying Earth, measuring time without keeping score. Whether it is coincidence or design, relic or companion, it has done its work quietly. And perhaps that quiet is the lesson. That meaning does not always announce itself. That gravity can feel like memory. That silence can still be full. We are small beneath that silver light, but not insignificant. We are brief, but capable of wonder. And wonder held gently is enough for one night. So let the questions rest where they belong, not solved, not dismissed, just held. The past is not finished. The universe is still thinking. Rest now, stay curious. Sleep, traveller, the cosmos will keep watch.